Hi, everybody. Thanks for coming to today's webinar. My name is John Handler. I'm a solutions architect with AWS, and I focus on Amazon Elasticsearch service. I'm joined today by Viraj Fant. He's a product manager on the Amazon Elasticsearch service team. Today, we're going to be talking about using Amazon Elasticsearch services cold storage tier, and more broadly, really sort of tiered storage within the service, the rationale, how to use it, what it does, and we'll end up with a quick demo of the tiered storage in Amazon ES. So just to sort of give a little background, Amazon Elasticsearch service is a fully managed service that makes it easy to deploy, manage, and run Elasticsearch cost effectively and at scale within the AWS cloud. We are also supporting an open source project named OpenSearch that is a 100% Apache licensed open source successor to Elasticsearch, including the plugins that we developed for our Open Distro for Elasticsearch project that enable you to deploy a secure and performant cluster in self-managed open source. We will be bringing OpenSearch into the service as the core engine going forward from version 7.2. At present, we're kind of in the middle of that transition, so we have some slides that have a little bit of mixed content. Mostly I'll be talking about Amazon Elasticsearch service, but OpenSearch will pop up, so just so you know, that's what we're doing. So again, just to stress the point, OpenSearch is a community-driven, it's open source, it's search and analytics derived from Elasticsearch 7.10.2. The project itself has an open source engine called OpenSearch and data visualization called OpenSearch dashboards derived from Kibana. And again, it includes all of the functionality ported over from Open Distro for Elasticsearch. If you're not familiar, and Elasticsearch itself has been out for about 10 years, and it supports two pretty distinct workloads. First and foremost, Elasticsearch is a search engine. As a search engine, it provides you with rich query capabilities on top of a catalog of data. You can think of something like a catalog of products, a catalog of websites. It's the usual search experience that you're so used to across all of the web and across all of your applications. It supports, again, rich queries, adjustable ranking to bring relevant results, language features for decomposing blocks of natural language text. It's search in a box. Now, as folks were out there using Elasticsearch, they began to throw log data in there. And Elasticsearch itself has developed to support a second workload based on this log or streaming data. These are analytics workloads where you need near real-time availability of your log data so that you can monitor your application, your infrastructure, your security, and make sure that the lights are on, things are working as they're supposed to. Again, in the open source world, we have Kibana. This provides you with the ability to build visualizations on top of the log data and have dashboards for monitoring and alerting. So for tiered storage, we're really going to focus in on this analytics workload. This is where you're generating usually a lot of data. And as you store this data for for near real-time analysis and potentially for future analysis, the cost structure is such that the cost is going to grow linear with the amount of data that you're storing. And so we came last year with UltraWarm, which enables you to store a longer retention window of data at a much reduced cost point. And recently, and the topic for the webinar, we have released cold storage, which enables you to detach indexes from your cluster and store that data at basically S3 cost. The core problem here is that machine-generated data is exploding. There's tons and tons of machine-generated data, usually around logs, telemetry, all of that kind of data. From your applications and infrastructure, you have services, you have microservices, web applications, business applications, APIs that you're building, and logging is behind almost all of this. In the IT and DevOps world, you want to monitor your databases, you want to look at your load balancers for what kind of traffic you have, you want to make sure that your networking is functioning, that you have that traffic is moving around, and the servers themselves, right? So all of this is more log data that you're generating in the back end. And then lastly, we have a big explosion in the IoT space, where for automotive, home devices, manufacturing, mobile applications, you have, again, logging that you're generating or telemetry that you're generating, and you want to be able to monitor that in real time. For all of these cases, you really want to be able to monitor in real time and have a longer tail for analysis. The core issue is that this data is very granular and hard to get a more forest views than a trees view, right? So I got an example Apache weblog here. You could have terabytes, petabytes, exabytes even of this data, and really it's a needle in a haystack problem. But the data actually has the valuable insights that you need around whether your infrastructure is working, what your latencies, what are your error rates, for issues, what caused them. For your security stance, do you have suspicious activity? Who accessed what? Is there fraud? For business, you want to know what are the products that my users are interested in. You want to know what features they use. You want to know what who's active, why are they active, what are they doing. All of that data is hidden in that enormous pile of log data. So with Amazon Elasticsearch Service, it enables you to pull all of that really granular data in and provides a mechanism for building insights on top of that data. When you use Elasticsearch Service, you're going to send in your log data. You have an interface that enables you to filter through that data to bring out different log lines. You have analytics capabilities that are numerical or bucketing for histograms across the values that you have in that data. And then Kibana is the tool that many people use. Grafana is another tool to connect to Amazon Elasticsearch Service. Kibana is a thin web client. It's running Elasticsearch REST API calls in the back to generate dashboards, visualizations that give you, again, that forest view, where you can pull the insights out of the unstructured log lines that you're sending in. With Amazon Elasticsearch Service, we're providing you an AWS service that enables you to do all of that with a much lower operational overhead on your end. So it's a fully managed service. When you use Amazon Elasticsearch Service, you deploy an Amazon Elasticsearch Service domain. This wraps software and hardware to deliver Elasticsearch to you at an endpoint where you send REST API calls. The process of spinning up and down Elasticsearch clusters is fully managed, and scaling up, scaling down, also managed. You do get access to the vast majority of Elasticsearch APIs, so you can store and retain all that data. You can use the Elasticsearch APIs. You can use Kibana, Grafana to build visualizations on top of that data. We provide features to manage your cost, especially for purposes of this talk. We're going to talk about the storage tiering and how that brings a more cost-effective structure to holding and analyzing all this data. We have a number of security features that enable you to authenticate and do access control to a fine-grained access control level, down to the field level with that access control. The service itself is highly scalable and highly available. We have features that enable you to build more available domains, and we have APIs that enable you to scale up, scale down at will. And we have some integrations with the AWS ecosystem that make it easier to get data from your sources into Amazon Elasticsearch Service. Just as we look at a sort of stack rank in terms of what the service offers, or a sort of stacked chart of what Elasticsearch service offers you. If we compare with self-managed, we have a number of things that you have to do on your own for running an Elasticsearch cluster, and including some of the core hardware and power, networking, HVAC, et cetera. If you're running on EC2, then obviously EC2 is going to take a portion of that that work for you in terms of hardware and power and networking. With the service, with Amazon ES, we have a number of features in place that provide you with additional functionality around Elasticsearch to make it more cost effective and easier for you just to focus on your application development and optimization. So I'm not going to go through this whole list, but we do provide a number of different things that take operational challenge off your plate. For anyone not familiar with Elasticsearch, Elasticsearch is at its heart a database technology, and the interaction model with Elasticsearch is very much a database interaction model. So we have at the left edge our sources, whether it's your servers, your applications, networking, AWS, other AWS services, any kind of log generator is going to be on the source side. The second set of sources is more for the search workload. You'll occasionally have application data. Elasticsearch works with a REST API, so you're going to format this log data as JSON and send that data to Amazon Elasticsearch service. Then within the service, the Elasticsearch cluster is then going to index all of the data that you're sending in. And one of the things that Elasticsearch, one of the differentiators for Elasticsearch, is that all of your fields are searchable. So as you're sending JSON in, even down to a nested level, you're able to use the individual JSON fields as a source for either filtering or searching across the data in there. And then finally, you're going to use REST APIs for fielded matching, Boolean expressions, sorting, analytics, et cetera. And you're going to use that to pull the data out of Elasticsearch. For the purposes of this discussion, we need to talk a little bit about data lifecycle, and we're going to go into more depth on this in a bit. But at a high level, when you use Elasticsearch, as I said, it's in the databases world, and you can make an analogy between a database table and an Elasticsearch index. So index is the main sort of bucketing structure within Elasticsearch for your data. So you're going to send your data in to particular indexes. Then that data is indexed in a hot tier within Elasticsearch. That hot tier provides you fast access on top of that as well. You're going to move that data from the hot tier into our ultra warm tier for lower cost, longer term retention. You maintain the same interaction with the data, it's just in a different storage tier and has a different performance footprint. Finally, when you're sort of done with the online analysis of that data, you're going to move it into cold storage, and then eventually you're going to delete that index. So this is sort of high-level view of the data lifecycle. This is how you interact with and manage your data inside Elasticsearch service. Under the covers, as I said, Elasticsearch is a database technology. It is a distributed database technology. When you use Amazon Elasticsearch service, you deploy what we call a domain. Within the service itself, that domain is hosted in a service-owned and operated VPC. We have a number of different instances within that VPC that provide Elasticsearch to you. The chief among those are the data nodes. Data nodes process the data, they do the indexing, they respond to queries. They're the sort of heart of the application. We also have ultra warm nodes. Ultra warm nodes enable you, again, longer term retention of data at lower cost. Then we have leader nodes. Leader nodes are the managers for the cluster of the Elasticsearch cluster. Leader nodes just retain state. They don't directly process any requests that come for data, whether it's indexing or queries. We have load balancer in front. And again, we provide all of this to you as a REST endpoint fronted or backed by that load balancer. You send in your queries and you send in your indexing requests. They're distributed across those data nodes. And then we also provide our OpenSearch security to do fine-grained access control against that data. On the security side, we also provide integrations for Kibana that provide you login and the ability to authenticate as a particular identity that you're going to use within Amazon Elasticsearch service to build roles that provide that fine-grained access control. So we integrate with Cognito, with AWS Identity and Access Management, IAM, and we also integrate with SAML providers for your Kibana login. I mentioned some integrations with other services. We send metrics about the Elasticsearch cluster to Amazon CloudWatch. We send audit information to CloudTrail, that is the higher level, who created domains, who deleted domains, et cetera. So with both of these, you can monitor your usage of Elasticsearch, respond to cluster needs in terms of scaling and resources in the cluster. On the ingest side, we have integrations with Kinesis Data Firehose, database migration service, CloudWatch logs through the console. Not a direct integration, but we do have many customers that use Kafka, whether managed or open source. So all of this provides you with additional ways to get data in and to monitor what's going on with your cluster. So let's talk about some of the storage tiers. I'm going to turn over to Viraj and let him talk about that.
Thanks, John. In this section, I'll be covering the storage tiers with Amazon Elasticsearch Service, hot storage, ultra-warm storage tier, and cold storage tier. Before we go into the details of the storage tiers, let us delve into the challenges that customers faced prior to the launch of ultra-warm and cold storage tiers that we introduced recently. Retaining infrequently accessed or older data at scale was cost prohibitive because they used either local storage, which itself was cost prohibitive, or used EBS that scaled linearly with the size of the data for their hot storage. Customers could not perform the same analysis on the data that was months old or even years old as they could in the hot tier. Customers could not self-service the archived data. That is, they did not have discovery features for data stored in S3. Older or infrequently accessed data is query intensive. Customers wanted to reduce the impact of such query intensive data on production clusters. To essentially solve these challenges, we launched two additional storage tiers, ultra-warm and cold storage, to complement the existing hot tier. Basically, now there are three tiers to Amazon Elasticsearch Service: hot tier, ultra-warm, and cold storage. Hot tier enables customers to keep recent data readily accessible and indexed in high-performance storage. It helps them query data and conduct real-time analysis. Ultra-warm and cold storage keep older data still available for analysis in a block storage or durable storage like S3. In order to overcome the challenges of retaining older data and infrequently accessed data in hot tier, as I said earlier, we introduced ultra-warm. Ultra-warm is a storage tier that reduces the cost per GB of data while still providing an interactive experience when searching and analyzing this data. It increases the amount of log data that you can retain and analyze in Amazon Elasticsearch Service by roughly a magnitude of 6x without increasing the cost. Ultra-warm storage tier data is stored in S3 with custom high optimized warm nodes used for indexing, caching, and querying data. You can use the same APIs and Kibana visualizations that you use today, even with ultra-warm. Ultra-warm lets you manage up to 3 terabytes of log data with a single Amazon Elasticsearch cluster. And as I mentioned before, you have the same interactive log, analytics, and visualizations experience. And if you compare the performance with the open source, hot, warm, or cold architectures, it's almost twice that you get with ultra warm. And recently in 2021, we launched a fully managed lowest cost storage tier to durably store infrequently accessed or historical logs at near Amazon S3 prices. And that is what we have as cold storage. So essentially, cold storage is a new lowest cost storage tier for Amazon Elasticsearch service. And with that, what you get is a lower cost. Basically, you no longer have to pay for the compute for data that you only need to analyze infrequently. This innovation was achieved by decoupling compute and storage. Now, you don't have to throw away the older data. You can generate valuable business insights from historical long tail data that you have. The simple discovery features enable secure access on data via self-service, and you can migrate the data you need to analyze from cold storage to your ultra-warm nodes in seconds. Essentially, now you do not have any limits on the data that you store in Elasticsearch clusters. As John mentioned, index state management is very important to migrate the data across tiers either manually or automating the data management lifecycle by setting up policies to migrate this data. You can use ISM or index state management to create policies and manage indices, and it can be administered in Kibana or via APIs. Essentially, with this, you can set up your policies. And what policies contain is basically the state, the transition, conditions, and actions. State describes the status that the managed index is currently in. Transitions are nothing but conditions that need to be met for a state to change. And actions are the steps that the policy sequentially executes on entering a new specific state. Now let us see how these come together in a sample policy that we can set up for migrating data from hot to warm to cold. This is an example policy that we have set up to move the data from the hot tier to ultra warm tier to cold, and then finally delete the indices. As you can see here, the hot data transitions to ultra warm after 7 days, and after 90 days it moves to the cold storage tier, and then finally after a year or 365 days the indices get deleted. What you also see over here is that you migrate to ultra warm with 5 retries. Essentially, that has been set up as a count in the retry function that you have. You can also attach these policies or move them by using 3 methods. One is directly through Kibana. Essentially, what you can do is click on the index management that you see on the left corner of your menu. And then from there, you select the indices that you want to move. And then finally, you apply the policy so that you can move the data from one tier to the other. You can also set the same policy by using templates or with APIs. Now, when you look at a particular policy that essentially supports a set of actions that help you migrate the data across one tier to the other. You also have the supported transition conditions that can help you manage these, especially when you're rolling over data from one tier to the other. Now let us go into the cold storage demo, and I hand over to John.
We'll start in our Amazon Elasticsearch service console. You can see we have a dashboard here that has lists out my domains, gives you some information about those domains. So I'm going to just give a quick overview of what it looks like when we create one of those domains. We do have some, we're going to step through a wizard. We have some predefined settings that you can use for production, dev, and test. I'm going to pick custom for this demo. You can see we support a number of different Elasticsearch versions going all the way back to 1.5. 7.10 is the latest. Our recommendation is always to choose the latest version of the software. We're going to give our name. So this is, let's say, hot, warm, cold logs. And we are going to then have a number of options that we can set. I'm going to just briefly touch on some of these, but I'm not going to go into any depth. So we do support a custom endpoint that enables you to bring a DNS name to your Elasticsearch service domain that is different. We have our auto tune feature, which when you enable it, does cluster tuning under the covers and provides a much better experience. We have, again, our multi-AZ feature, higher availability. We do recommend 3 availability zones for all production workloads. For dev and test, it's okay to do 1 or 2 AZ deployments. Again, a number of instance types in the service that we can use for our data nodes. We're seeing really nice performance out of our Graviton instances. And I'm just going to go with our R6 GD Graviton instances. We're going to deploy 3 data nodes across our 3 availability zones, 1 in each zone. For the storage, well, the R6 GDs, GDs have instance storage. I actually wanted the R6Gs. Where are those? There they are. So we're going to go R6G. For our storage on our hot nodes, then we either have instance storage. These are NVMe SSDs for our i3 instances and the R6GD instances. And we also have EBS-backed storage for nodes that are EBS. So for EBS, we recommend the general purpose. We'll put some storage on this. That is the per node storage amount. We do recommend dedicated master nodes for production deployments. And those, again, give you the additional stability through having a cluster manager. So to the point of the conversation, we have then our ultra warm and cold storage. So we're going to enable our ultra warm nodes, and we're going to select between medium and large. With our medium nodes, we support up to 1.5 terabytes of storage. And with our large nodes, we support up to 20 terabytes of storage. And when we're thinking about the storage here, the ultra warm tier does not use replicas directly. And so the sizing here is really, we're only going to use the primary shards for this index sizing. We're going to use 3 warm data nodes, again, 3 zones, 3 warm nodes. We're also going to enable cold storage. This enables us to, again, detach those indices and bring them onto the cold tier. We then have access and security. We recommend VPC. I'm going to actually skip through this and go to the one that I have in the oven, all ready to go. So let's break out of this. And I have a domain that I've been running for nearly a year now with data that's come to my CloudTrail in my account. If you're not familiar, CloudTrail actually, again, receives logs from across AWS services that enable you to track who's doing what within AWS. You can see here we have a number of different tabs to provide different features and functionality. We have our cluster health. We have a lot of instance and cluster KPIs right here on our console. Also, these metrics go off to CloudWatch, so you can access CloudWatch for anything that doesn't come up here. This error is because I haven't provided access for the console to get to my domain. We also have per instance metrics. These, again, give you things like how much storage you have, what's your search rate, CPU, and latency on a per instance basis. So that's some of the functionality that we provide in the console. What I'm going to do is we also provide you with your, sorry, I have to go back to my overview tab. We provide you with your Kibana endpoint. And this enables you, again, to run Kibana on top of this data. Coming in and looking at Kibana, then I'm not going to do a deep demo of Kibana itself. I'm just going to quick pop up a dashboard to give you an idea of what you can do. This is, again, based on my CloudTrail data. We're looking at the last 15 minutes of data. And you can see I have calls broken down by region. East and West are what my account's using right now. This is the event sources. So I'm calling ES is Amazon Elasticsearch service, KMS is our key management store, S3, et cetera, et cetera. So I get a little heat map here. I can also see where my traffic is coming from and what is happening to it. We even have a tag cloud that lets me know some of the AWS APIs, basically by size. We can also build graphs like this one that gives me a line graph in terms of how many bytes of data are coming into S3, where my event sources are coming from over time as a line graph. All of this data, then we are able to monitor what's going on in the account. So to look at what's behind this, I'm going to go to my index management tab. And you can see in this tab, we really are dealing with the hot, warm, cold indexes, with the policy creation, with attaching policies to these various indices. So if I look, let's look at my policy here. So this policy is pretty much the same as the one that Viraj showed you in the presentation portion. This is a hot, warm, cold. I started my hot state. I'm going to transition to my warm state after 7 days. I'm going to transition to my warm state. In my warm state, then I'm going to perform a warm migration. And I'm going to try for 24 hours, at least 5 times, to migrate over into the ultra warm tier. So this warm migration is what's going to move the data into the ultra warm tier. We're going to transition from the ultra warm tier to the cold tier. That's going to happen after 90 days. In my cold state then, and this cold migration, if I can get it back on the screen, is going to happen in here. And I'm going to move that data off of the cluster. Then at the end, after 365 days, I'm going to delete this index. I'm going to transition to my delete state. In my delete state, I delete the index, cold delete, and I notify via mustache template, I notify myself via chime that I'm deleting this index. One very important thing in this policy, you are able here to template the application of this policy to various indices based on a wildcard. So all of my data coming from CloudWatch logs is CWL star. Actually, the CloudTrail data is going to CloudWatch logs and then to Amazon Elasticsearch service. So all of this data is coming from CloudWatch logs. I'm applying this policy to CloudWatch logs, all of my CloudWatch logs indices. This is how you automate the application of policies to indices so that you don't have to manually do it. We can look on this cluster. There's a number of various indices here. We're going to do something with the Kibana sample data logs in a second. What you'll see though mostly is that I have 1, 2, 3, 4, 5, 6, 7 days of hot data here. Again, these are the hot indices, and these are all these CloudWatch logs indices. In my warm tier, I have only 83 days. I had an older policy that was truncating after 90 days. So I have a total currently of 90 days, 7 hot, 83 warm. And I have at the moment a few indices that I manually, oh no, these are actually, this policy went into effect. So data older than 90 days is actually here. And you can see it's going back in time quite far. So I have a number of data here, a number of indices, 260 in my cold tier. I can also look at my policy managed indices. This lets me look within my indices for, let's see if I have 08, if I can do that. And you'll see there are 9 that are in August of 2021. And these are all mostly hot. So I can use this tab to dig in and figure out what indices I have, where they are, and work with that data. So let's do a quick migration here. I'm going to go over to my DevTools. The DevTools tab here lets me run commands against the cluster. So we have our Kibana sample data logs index, and by API, if I'm not using index state management, I can also do all of this manually, right? So I'm going to manually move the Kibana sample data logs to the warm tier. So while it's migrating, then I can get the status. What happens sometimes here is that the migration is so fast that we actually miss the status update. So if we go over to the index console and we look at our hot indices, we'll see we do have a couple of hot indices, the flights data and the e-commerce data, but we don't have our logs data here. If I look at my warm indices, you can see Kibana sample data logs has migrated to the warm tier. So let's go back to our DevTools and quickly, I'm going to run this query that is a match all query. It's just going to be a quick query against that data, just to show that in this query itself, we're not actually monitoring, or we don't have to know what storage tier the data sits in order to run a query against it, right? So in this case, I can run the query, I have results. Actually, if I go back to my dashboard, I can expand this out across 7 days, and I'll see, actually that is not including, let's go last 30 days. You can see here I'm running across 30 days of data. That includes the 7 days that are hot, but also 23 that are in ultra warm. You can see our performance is decent here as well. If we had a lot more data, this query would eventually slow down as the ultra warm tier works with S3 to bring that data across and query it. But the interaction model itself, like again, I don't have to know what tier the data is in. I just build my dashboard and I can expand my time range across the hot and warm data. So coming back to our DevTools, we can now move that data into the cold tier. You can see here I have my call. I'm going to move my ultra warm data into my cold tier. I'm going to move the sample data logs. Again, this is a fast command. We should be able to go to our index tab and look at our cold indices. And here we have Kibana sample data log showing up. So the data is now in the cold tier. Data in the cold tier is not something that you can query directly. So if I go back to my DevTools and I try my same query here against the Kibana sample data logs, no index found. And that's expected. The index itself is only in S3. It's been moved entirely out of this domain. We can then move that data back to the warm tier to enable querying that data. So I'll move that data now. Again, it's a quick command. I imagine it's already completed. Let's go ahead and search that data. And you can see that data is back in the warm tier. I'm able to search that. I could, if I needed to change this data in some way, I could actually move it back to the hot tier, make changes to it, migrate it to the warm tier again, and then to the cold tier to drop it off. So this is how you interact with the various indices in the different storage tiers within Amazon Elasticsearch Service. And just cover a couple of quick links and getting started points. We have a number of different resources here. We have our cold storage feature description, our pricing, our FAQs, new releases, developer guide. Many of our blogs have posts about Amazon Elasticsearch Service, including cold storage. And if you want, please contact us at the below link, Elasticsearch Service PMs at Amazon.com. If you go to those links, it's really easy to get started with Amazon Elasticsearch Service. Create an account. You can, as you saw, launch an Amazon Elasticsearch Service cluster in minutes. And then we have a whole tutorial that walks you through building a log analytics solution. Thank you again for your time and your attention today. It's been great talking with you.